Algebra 1, Lesson 16, Slope of a line. In the last lesson, we discussed the coordinate plane and how we can use coordinate points to mark locations using the x and y coordinates. We also learned how we could plot different coordinate points and analyze the distance between them. In this lesson, we will learn how to measure a rate of change between 2 points by drawing a line through them and calculating the slope. The slope of a line is a measure of how steep the line is. It is also defined as the ratio of the change in the y-coordinates to the change in the x-coordinates between any 2 points on the line. If we define the coordinates of 2 points on the line as x1, y1 and x2, y2, then the slope of the line, denoted as m, can be calculated using the following formula: m equals y2 minus y1 over x2 minus x1. The slope can be positive, negative, 0, or undefined, depending on the direction and steepness of the line. A positive slope indicates that the line is moving up and to the right, while a negative slope indicates that the line is moving down and to the right. A slope of 0 indicates a horizontal line, while an undefined slope indicates a vertical line. Let's calculate the slope of a line between 2 coordinate points, draw it on the coordinate plane, and analyze the steepness of the slope. Example 1. What is the slope of the line between points 1, 4, and 3, 2? To solve this problem, we refer to the slope formula and plug in all the points where they need to be. Let's take a look at the formula again. So, if we plug in the numbers correctly, we will get 2 minus 4 over 3 minus 1. Evaluate and we will get minus 2 over 2, which equals minus 1. Looking at a graph of the line going through both points, and knowing that the slope is negative, we can see that the graph has the right orientation of the steepness of the slope. Example 2. What is the slope of the line between points 3 minus 5 and minus 6 minus 5? Like with the previous examples, we plug in the coordinate points into the slope formula. We get minus 5 minus minus 5 over minus 6 minus 3, which equals 0 over minus 9. This gives a slope of 0, meaning that the line is flat and not steep. We'll show you the graph in the next part. As you can see, the horizontal line goes through point minus 5 in the y-axis. This means that the distance between any 2 points on the line will have the same slope of 0. Example 3. What is the slope of the line between points minus 7, 8, and minus 7, 14? Let's chug through this one like we did the last 2 examples. We plug in the coordinate points into the slope formula. We get 14 minus 8 over minus 7 minus minus 7, which equals 6 over 0. Houston, we have a problem. The math gods have been alerted because you probably thought you could divide by 0. Foolish mortal. This gives an undefined slope, which will be shown on the upcoming graph. This graph shows a vertical line going through the x-axis. This line is infinitely steep, so its slope is undefined. This happens when we calculate the slope formula and end up with a 0 difference between the 2 x-coordinates in the denominator. Why don't we say that the slope is infinity instead of saying it's undefined? Well, go take that up with the math gods and get struck by lightning if you want to. That's just how it is. Higher-level math courses will go deeper into the distinctions, but for now, let's just say the slope is undefined and not Phi. That's our lesson on the slope of a line. The slope formula will become important in our next few lessons, so it's a good idea to get some practice using it. Recognize the orientations of positive, negative, zero, and undefined slopes on a coordinate plane as well. See you in the next lesson.